Welcome to the deep dive. Today we're getting into cybersecurity. It's everywhere, isn't it? It really underpins our whole digital lives.
Absolutely. And, to really get a feel for it, reading theory isn't enough. You kind of have to jump in.
Exactly. That's why we're going to be looking at capture the flag competitions today. CTFs. They're like a hands-on training ground for these skills.
Yeah, learning by doing, basically. And the material we're drawing from today, it's straight out of a cybersecurity bootcamp.
Right. So our plan is to pull out the key ideas, make them really clear, maybe even a bit fun. Whether you're just starting out or need a refresher, this should be valuable.
Okay, so first things first. What actually is a capture the flag competition? A CTF.
Good starting point.
Yeah.
Imagine it like a set of challenges, right? All focus on cybersecurity problems.
Like puzzles.
Exactly like puzzles. It could be anything from, say, cracking some code, hacking into a simulated system, or maybe just finding information hidden somewhere obscure.
And the goal?
The goal is always to find the flag. It's usually just a specific string of text, kind of like a secret password hidden within the challenge.
And finding that flag proves you solved it.
Precisely. It's your evidence. The more flags you grab, typically the higher you rank. And you can do these solo or often as part of a team. It's a brilliant way to test what you know.
Okay, now a lot of these CTFs and definitely the bootcamp stuff heavily involve Linux. Why is Linux so central to cybersecurity?
That's a really core question. Linux, well, it's kind of taken over in some critical areas. I think supercomputers, almost all of them run Linux.
And the internet's backbone, right?
Yeah, a huge chunk of the world's web servers run on some flavor of Linux.
Plus, it's not just the big stuff.
No, definitely not. Your phone, if it's an Android phone, it's running on a Linux kernel underneath. So, yeah, if you're serious about this field, you really need to understand Linux.
So the bootcamp materials point you towards the Linux command line, usually an icon called terminal, maybe with a little sign.
Yep, that black box, that's your entry point.
And when you open it, you get that prompt, right? Like user at machine or something similar. What does that actually tell you?
Okay, yeah, it looks a bit cryptic maybe, but it's giving you useful info. The bit before the @ that's your username.
Okay.
After the @ is the host name, the name of the computer you're on. Then that little squiggle, the tilde, that usually means you're in your home directory, your personal space.
And the final symbol, the dollars or sometimes a hashtag.
Yeah. That's super important. A $, usually means you're logged in as a standard regular user, limited permissions.
That's the hashtag.
The hashtag means you're root. The administrator, you have full control over the system.
The super user. So you need to be careful with that one.
Oh, definitely. With great power comes great responsibility.
Yeah.
Right? You can break things easily if you're not careful as root. Now, how do you actually do things? You use commands. Can you give us a simple command structure example?
Sure. Let's take #-J 2024. DEFCON is the command itself, tells the system you want a calendar. The -J part, that's an option or a flag. It modifies how Sockle behaves. In this case, it means show Julian dates.
Got it.
And 2024 is a parameter or argument. It tells a Sockle which year you're interested in. So it's generally command, options, parameters.
And options often have short and long versions, don't they?
They do. Like the date command, you can use SU for universal time, or you can spell it out with universal. Same result, just different ways to write it.
Handy. And if you forget how a command works, which happens a lot, let's be honest.
Oh, all the time. Linux has built-in help. You can often type the command followed by EQ or help. So tcpdump feh should give you a quick summary.
Or the man pages.
Yes. Man, tcpdump. That brings up the manual page, which is usually much more detailed, like a full instruction booklet for the command. Incredibly useful.
Right. So you're at the prompt. How do you move around the file system? Where am I? How do I go somewhere else?
Good questions. To find out where you are right now, use pwd.print working directory. Simple. To change directory, it's cd, followed by where you want to go. So cd varlog takes you to the log directory.
What about going back up?
cd. The 2 dots mean the parent directory, the one above where you are.
And back to where I just was.
Handy shortcut, cd. That toggles you back to the previous directory.
Nice. And home.
Just cd by itself, or cd, that tilde again, takes you straight back to your home directory.
Okay, navigation covered. Now, how do I see what's actually in a directory?
That's the ls command, list directory contents. Just typing ls gives you a basic listing.
But usually you want more detail, right? Hidden files?
Yeah.
Permissions?
Exactly. For that, you usually use lslat. The LSL gives you a long listing format with details, and the shows all files, including hidden ones that start with a dot.
And you can specify a path too, like ls, lay, etc., to see inside the etc. directory.
Yeah, absolutely. And when you look at that L output, notice the first character on each line. It tells you the type.
Right, like D for directory.
C for directory, L for a symbolic link like a shortcut, and just a -mats for a regular file.
And then there's that string of letters like RWX, ARTHXR, permissions.
Exactly. Those are the permissions. R means read access, RW means write or modify access, and X means execute access.
Execute for programs, right? Or for directories.
Both, actually. For a file, X means you can run it if it's a program or script. For a directory, X means you can enter it, like with the CD command. Without X on a directory, you can't even go inside it.
How do you change those?
With the chmod command. Change mode. You can use letters like U for user, G for group, O for others, or A for all. Then plus to add a permission or to remove it, followed by R, W, or X.
So, like chmod aw secretfile.txt would remove write permission for everyone.
Precisely. Or chmod U plus X, myscript.esh would give the user execute permission for that script. Permissions are really fundamental to Linux security.
Okay. Creating stuff now. How do I make a new folder?
MP in your make directory, just MP under me folder.
What if I need to make a folder inside another folder that doesn't exist yet?
Use the -p option, .mkdr app project data raw. That'll create project, then data inside it, then raw inside that, all in one go if they don't exist. Super handy.
What about spaces in names, like mkdr my work files?
Yep, put the name double quotes if it has spaces. And remember, Linux is case sensitive. File.txt and file.txt are totally different files.
Gotcha. Okay, managing files now. Copying, moving, renaming, deleting.
Right. CPP is for copy.cp source file destination directory, or CP source file new file name to copy and rename.
And moving or renaming.
That's mv.move. It works similarly. MV old file new location, or MV old file name new file name.
And the dangerous one.
Deleting.
RM, remove.rm, unwanted file.txt. Be careful.
Especially with -rf.
Right, oh yeah. rm-rf, some directory. The offer means recursive, so it deletes everything inside the directory too. The -f means force, so it doesn't ask you, are you sure?
Like.
Yeah. rm-rf is the classic wipe your entire system command. Don't do that unless you really mean it. Use rm with extreme caution, especially -rf. Duly noted.
Yeah.
Okay, sometimes you know a file exists, but you don't know where. How do you search?
The find command is your friend there. It's really powerful. To search for a file named config.ini starting from your current directory downwards, you'd use find.nameconfig.ini.
The dot means current directory.
Yep. And if you don't care about case, use in-name instead of name, like find home in-name report.pdf to find any PDF with report in the name, ignoring case. The asterisks are wildcards.
Okay, so you've found your file. How do you peek inside?
Several ways. For plain text files, cat just dumps the whole content to the screen. Cat echoes.
But if it's a long file?
Then use more or less. They show the file one screenful at a time. Use spacebar to go down, B to go back in less, and Q to quit either of them. Less is generally more powerful.
What about non-text files, like programs?
You can try the strings command. It attempts to pull out any readable text sequences from any file. Strings bin bash will show you some interesting stuff.
And saving command output.
Use the redirect symbol .ls-l directory listing.txt, saves the output of ls-l into that file, overwriting it if it exists. Use to append instead of overwrite.
Useful. What about figuring out what kind of file something is?
The file command is great for that. File my document might tell you it's a PDF or a JPEG image or a shell script.
And for more metadata, like timestamps.
Use stat. Stat-importantFile.doc gives you detailed info like last access time, modification time, creation time, permissions, etc.
Okay, now a really common task. Searching inside files for specific text.
GRIP. Global Regular Expression Print. Absolutely essential. To find lines containing the word error in a log file, grep error varlog syslog.
Can you filter out lines?
Yep. Use the -v option for invert match. grep-v successresults.log shows lines that don't contain success.
What about seeing context? Lines before and after the match.
-b for before, A for after.
Yeah.
grep-b2-a5 critical failure system.log shows 2 lines before and 5 lines after each match.
Case-insensitive search.
grep-i password config.txt.
And searching in all files within a directory in its subdirectories.
@gnar for recursive. grep apikey oftmyapp. You can combine these two, like grep tang-urin secret data to recursively search case insensitively and show line numbers. And
super powerful. Okay, sometimes you only need the start or end of a file, like logs again.
Head shows the beginning, tail shows the end. By default, they show 10 lines. Use #n to specify how many, like head n50 access.log.
And tail-f is the magic one for watching logs live.
Exactly. Tail-f varlonhero.log follows the file, printing new lines as they're added. Hit Ctrl+C to stop it. Essential for monitoring.
Right. In CTFs or pen testing, you often need to download stuff from the web. Command line tools for that.
Two main ones, wget-dead and curl.
Yeah.
wget-https.example.com. For that shadewile.zip just downloads it. You can use -o to specify the output file name, wget-ed-o myarchive.zip.
And curl.
Curl is more versatile, can do lots more than just download, but for basic downloading, curl-o local file name.txt https.anothersite.com//-o/data-o specifies the output file. Both are indispensable.
Okay. Now, piping. That vertical bar, what's that about?
Piping is incredibly powerful. It lets you take the output of one command and use it as the input for the next command. Chain them together.
Like filtering a ls output.
Exactly. ls, etc., greps less everything in, etc. Then pipes that list to grep, which filters it to show only lines containing /. Very common pattern.
Nice. And base 64 encoding, decoding comes up sometimes.
Yes, simple built-in commands. Echo secret database 64 will encode it.
Funky coding.
Echo C2V JCMV0IGRGRGGEK base 64 -G and GID. DID is for decode.
Cool. Last basic Linux thing, managing software packages, updates, installing stuff.
On Debian-based systems like Ubuntu or Kali, which are common in this field, you use apt or apt-get. First, always update your package list. Sudo apt-get update.
Sudo, because you need admin rights.
Right. Then you can search for packages .apt-cache, search Nmap. And to install it, sudo apt-get install Nmap. It'll usually ask you to confirm.
Okay, that's a solid Linux toolkit. Absolutely vital groundwork. Now let's zoom out a bit. Talk about the typical fissures of a hack, because these often structure CTF challenges.
Right. There's a generally recognized flow, though it's not always perfectly linear. It usually starts with reconnaissance gathering info.
Spying, basically.
Kind of. Then scanning and enumeration, actively probing the target. Then gaining access, the actual breach.
Getting in.
Then maintaining access, keeping that door open, covering tracks, hiding your activity, and sometimes escalation of privileges, trying to get more power on the system, like going from a standard user to root.
Let's dig into that first phase, reconnaissance, passive versus active.
Okay, passive reconnaissance is gathering information without directly interacting with the target's systems. Think public sources.
Like what?
Internet searches, looking up who owns a domain name, WHOIS lookups, checking archives of old websites, social media profiling, job postings, anything that doesn't send packets directly to the target shouldn't know you're looking.
And active reconnaissance.
That does involve interacting with the target, like scanning their network ports or sending probes to web servers. This carries a risk of detection.
What are some tools for passive recon?
Oh, tons. There's the OSINT framework website, which lists loads of resources. The Wayback Machine for historical website snapshots. Shodan, which is like a search engine for internet-connected devices, routers, cameras, servers, etc.
Scary stuff.
Can be. Also, tools like What's My Name to check username usage across sites. And, of course, never underestimate good old Google.
Ah, Google Door Key.
Exactly. Using Google's advanced search operators to find specific information that might not be obvious.
Like cite, to limit results to one domain.
Yep, site.target.com. Or in url.admin to find URLs with admin in them. Filetype.pdf, confidential, to find PDFs with the word confidential. You can combine these.
There are databases of these dorks, right?
Yeah, the ExploitDB Google Hacking Database, GHDB, is a classic. Loads of pre-made queries to find potentially sensitive stuff like login pages, exposed config files, error messages, etc.
Okay, so after passive recon, you move to scanning and enumeration, actively poking the target. What's the main goal here?
You're trying to map out the target's network presence. Find out which IP addresses are live, what services are running on them, and what ports those services are listening on. It's like checking which doors and windows are unlocked.
And the foundation here is the IP address, right? The network address.
Exactly. Every device on a network needs an IP address to communicate. It could be a private one, like 192.168.1.5 on your home network, or a public one, like 8.8.8.8 out on the internet. Knowing the target's IP is step one for active scanning.
And services listen on specific ports, like mail on port 25, web on 80.
Correct. Ports are like numbered doors on the IP address. Standard ports exist for common services, 80 for HTTP, 443 for HTTPS, secure web, 22 for SSH, secure shell, 21 for FTP control, 25 for SMTP email. Knowing which ports are open tells you what might be running there.
And the tool everyone uses for this is Nmap, right?
Oh yeah, Nmap, Network Mapper. It's the absolute standard for network exploration and port scanning. It can find live hosts, identify open ports, detect the services and versions running on those ports, even guess the operating system. It's incredibly versatile.
How does it actually check if a port is open? What's the basic idea?
For TCP ports, the most common scan, the default SYN scan, is quite clever. Nmap sends a packet with just the SYN flag set to the target port.
Like asking to start a connection.
Exactly. If the port is open and a service is listening, the target sends back a SYN packet, acknowledging the request and asking to connect back. Nmap sees this, knows the port is open, but instead of completing the connection with an ACK, it sends an RST reset packet to tear it down immediately.
So it doesn't fully connect. Stealthier.
Relatively, yes.
Yeah.
It's often called a half-open scan. If the port is closed, the target just sends back an RST packet straight away in response to the initial SYN. Nmap sees that and knows the port is closed.
By default, Nmap scans, what, the type 1000 ports?
Usually, yes. The 1,000 most common TCP ports, a basic scan is just nmap target.example.com.
How do you specify ports?
Use the NoApp-P. 80,443,880 target.com scans only those 3 ports. To scan all 65,535 TCP ports, use nmap-PSP16555 target.com. Be warned, scanning all ports takes much longer.
What about UDP ports?
UDP scanning is trickier because UDP is connectionless. You use -SU, often combined with top ports, like nmap-SU top ports 100 target.com to scan the 100 most common UDP ports.
Knowing just that a port is open isn't always enough. You want to know it's running right. The service version.
Absolutely crucial. That's the -SV option for service and version detection. Nmap-SV-FP 22,080,443 target.com. This tells Nmap to probe those open ports and try to figure out, okay, port 22 is open. Is it open SSH version 7.6 or something else? Knowing the version lets you look for known exploits.
And the H option. Aggressive scan.
Yeah, AA is a shortcut for enabling several useful things at once. OS detection, LRO, version detection, -SV, script scanning, -C, and trace route. It gives you a lot of info, but is definitely not stealthy. nmap-aj.com.
Can you control the speed? Make it quieter.
Yes. With the timing templates, -TT0 is paranoid, very slow evasive. -T1 is sneaky, -T2 polite, -T3 normal default, -T4 aggressive faster, and -T5 insane, very fast, very noisy. So nmap-T2 target.com would be slower and less likely to trigger alarms than the default.
We mentioned OS detection, OS, and default scripts, -SC. What do the scripts do?
Nmap has a scripting engine, NSE. -SC runs a default set of scripts considered safe and useful. They might check for anonymous FTP login, grab web page titles, look for common vulnerabilities, etc. There are thousands more scripts you can run for specific tasks.
Can you specify TCP and UDP ports together?
Yep. Nmap-P T-Type-1 25 millithousands 443 U.53161 target.com. T for TCP ports, U for UDT.
And saving the results?
-N out N filename.txt saves in normal human-readable format. -OX filename.xml saves in XML, good for parsing with other tools. -OA basename saves in all major formats. Normal, XML, greppable, using that basename. Nmap-OA scam results target.com.
Absolutely. DNS translates names like www.google.com into IP addresses computers understand, but DNS records hold more than just the main IP. They can reveal mail servers, subdomains, text records with verification codes, lots of useful info for recon.
How do you query DNS? Basic tools are usually built in. nslookup-example.com or hostexample.com give you the primary IP, the A record. Dig is more powerful. Digexample.com gives more detail. Digmxexample.com specifically asks for the mail exchanger, MX records. Diganyexample.com tries to get all record types it can find.
And DNS enumeration is about finding things that aren't obvious, like subdomains.
Exactly. Trying to discover host names like dev.example.com, internal.example.com, vpn.example.com that might not be linked publicly.
Yeah.
This is often done using brute force with word lists.
Tools like GoBuster again.
Yep, GoBusters can do DNS enumeration, also tools like DNCnum and DNS Recon. You give them a domain and a word list of common subdomain prefixes like www, mail, FTP, dev, test, etc. And they query DNS for each one to see if it exists exists.
Can be noisy, though. Lots of queries.
Can be, yeah. It's definitely active enumeration. If GoBuster isn't installed, sudo apt-get install GoBuster seeklists often gets the tool and some good word lists. To run it for DNS, GoBuster DNS dws.emain.com-w path to subdomain wordlist.txt.
Okay, moving from DNS to the web itself. Web enumeration.
This is about exploring a website's structure, finding hidden directories, files, admin pages, interesting parameters, maybe leftover backup files. It's like mapping out the website beyond just clicking links.
What tools are common here?
Tools like Derb, Dirbuster, which has a GUI, GoBuster, using its dir mode this time, and Nikto.
And as we probe websites, we get HTTP response codes back. Which ones are particularly important?
Yeah, understanding these helps. 200 OK is good means the page exists and you got it. 404 not found means the page or directory doesn't exist. 403 forbidden means it exists, but you don't have permission to view it. Interesting. 401 unauthorized means you need to log in, often triggers a username password prompt. 301 302 redirect means the page has moved elsewhere. These codes give clues.
Let's look at Derb. How does that work?
Derb is a classic command line web content scanner. You give it a base URL, and it tries appending common directory and file names from a built-in or specified word list. Basic usage, derb http.targetsite.com.
Can you customize it? Like stop it from going into subdirectories it finds?
Yep, that tells it not to recurse. Derb http.targetsite.com nashar. You can add a delay with Nergy in milliseconds to be less aggressive. Derb darby and Nergy 500. Change the user agent string it sends with Burp AM Mozilla 5.0. Use a custom word list by just adding the path at the end. Derb http.targetsite.com USR share word list dobecommon.txt.
And GoBuster for directories.
Similar idea, but you use the dir mode. GoBuster derb add draby http.targetsite.com-w USR share word lists dirbuster directory -list 2.3-medium.txt.
Useful options for GoBuster dir.
A for user agent, -e for expanded mode, prints full URLs. -x to specify file extensions to look for, like -x-php-txt-html, -ash to follow redirects. -su and -edgy if the site needs username password authentication.
Finally, Nikto. That's more of a vulnerability scanner, right? Not just finding directories.
Correct. Nikto specifically looks for known web server vulnerabilities, dangerous files, outdated software versions, configuration issues. It's less about discovery and more about finding specific weaknesses. Run it like nikto-http.targetsite.com.
Can it scan multiple ports or SSL sites?
Yes. -pp to specify ports. nikto-h-targetsite.com -p 80,080 MAWay. And -SSL if the site uses HTTPS. nikto-targetsite.com -p 443-SSL.
Okay, so enumeration gives us a map and potential weak spots.
Yeah.
Now let's talk about exploiting common web vulnerabilities. The OWASP Top 10 comes to mind.
Yeah, the OWASP Top 10 list is a great starting point, highlighting the most critical web application security risks.
Let's cover a few common ones mentioned in the materials. First, local file inclusion LFI. What is it?
LFI happens when a web app lets you specify a file to be included or displayed maybe through a URL parameter like .pagecontact.php, but it doesn't properly check what file name you provide.
So you could trick it into including a different file.
Exactly. Instead of contact.php, an attacker might try to include a sensitive system file.
How do you spot and test for this?
Look for parameters in URLs like file, page, include, path. Then try path traversal. Use .sequences to try and move up the directory tree. A classic test is trying to access, etc. password on Linux, .file, etc. Pass WD.
The dot goes up one directory.
Right. Repeat it enough times, and you might break out of the web root directory and access system files. Another trick is using PHP filters if the site runs php.file, php.filterconvert.base64, co-encoder sastpd. This might bypass simple checks and return the file content encoded in base64.
The materials show vulnerable PHP code. Include gawk file. That looks bad.
It's terrible. It takes the file parameter directly from the request, getT or post, and includes whatever path is provided. No validation at all. Perfect LFI vulnerability. Other risky PHP functions are includents, requirements, fopen if used with user input without sanitization.
The breaking news scenario uses LFI.
Seems like it. News site, article parameter like .article politics, the task suggests trying path traversal on that parameter to read, etc. to password, and ultimately find a flag in varbackupsecret.txt. Classic LFI challenge flow.
Okay, next big one. SQL injection, SQLi. First, what's SQL?
SQL is structured query language. It's the standard language for talking to relational databases, storing, retrieving, updating data. Almost every website with user accounts, products, posts, etc. uses a database and likely SQL to manage it.
Like for checking logins.
Exactly. A login page might run an SQL query like select from users, where username, user input, and password equals password input.
So SQL injection is injecting SQL code.
Precisely. If the web application takes user input, like from that login form, and puts it directly into the SQL query without cleaning it first, an attacker can insert their own SQL commands.
What can they do with that?
All sorts of nasty things. Read sensitive data from other tables, modify or delete data, even bypass the login check entirely.
How do you bypass a login? The example uses AR1 equals 1.
Right. If you put that into the username field and the application just pastes it in, the query might become something like, where username R1 and 1 at passage.
But 1 is always true.
Always true. And the at the end is in SQL comment, making the database ignore the rest of the line, including the password check. So the condition becomes true, and boom, you might be logged in without a valid password.
Wow. Finding and exploiting these manually seems tedious. That's where SQL Map comes in.
Exactly. SQL Map is an amazing automated tool for detecting and exploiting SQL injection flaws. You point it at a URL, tell it about any parameters, and it figures out if it's vulnerable, what kind of database it is, and then lets you do things like dump database contents.
Basic usage.
SQLmap-u http.vulnerable.sitepage.php.id1. If it's a picoCTF request, like a form, you might use data user test and pass test. There's also wizard mode that walks you through it.
Useful commands within SQL Map.
Once it confirms a vulnerability, db-des lists databases, db name tables lists tables in a specific database, -db name dash table name columns lists columns, and -d db name -d table name dump extracts all the data from that table. Users and passwords try to get user credentials.
The example shows dumping the user's table.
Yeah, something like SQLmap newest data, dump depots users. It would then try to retrieve all rows from the users table, often including usernames and hashed passwords. SQL Map can even try to crack those hashes for you using built-in dictionaries.
Scary powerful. Okay, another critical one. Remote code execution, RCE. What's that?
RCE is pretty much the holy grail for an attacker. It means they can run their own arbitrary commands or code directly on the target server. Full control, essentially.
How does it happen?
Often due to, again, poor input validation. If an application takes user input and uses it unsafely in a system command, that's OS command injection or shell injection, or if file uploads aren't handled securely.
How do we test for OS command injection?
Look for places where the app might be calling system commands, like maybe a tool that lets you ping another host. Then try injecting shell meta characters, semicolon to run another command after the intended one, target.com and ted, pipe to chain commands, target.com warmy, ampersands and evit for logical AND, target.com and sleep 5. If it pauses for 5 seconds, it likely executed the sleep command.
And file uploads leading to RCE.
If a site lets you upload files, like profile pictures, documents, but doesn't properly check the file type or content, you might be able to upload a web shell.
A web shell.
It's a script, like PHP, ASP, JSP, that once uploaded and accessed via the browser, gives you a command prompt or interface to run commands on the server. A simple PHP one might be just .php system, ggtcmd, upload that as shell.php, then access victim.com/shell.php.cmdls to list directory contents. More advanced shells offer graphical interfaces.
Security misconfiguration is mentioned too. That sounds broad.
It is. It covers a huge range of mistakes, leaving default usernames and passwords unchanged, like admin, unnecessary features or services enabled, verbose error messages that leak internal details, outdated software with known vulnerabilities. Basically not hardening the system properly at any level, OS, web server, database, application framework.
And vulnerable and outdated components ties into that.
Exactly. Using libraries, frameworks, or other software components with known security holes that haven't been patched. A huge attack surface.
The materials have a CTF web hacking checklist. Key takeaways.
Yeah, it's a good summary. Always check the page source code. Cedar Trill plus U in most browsers. For comments or hidden fields, run nicto, do directory enumeration, derp go buster. Test for LFI and RCE. Test all user input forms, URL parameters, headers, and definitely check file upload functionality if it exists. It's a methodical process.
Okay, so you've found a potential way in, maybe a login page or an SSH service. Now, brute forcing, what's the core idea?
Brute forcing is just trying guess credentials, usernames, and passwords over and over again until you find a combination that works. It's methodical guesswork, usually automated.
Where do the password guesses come from?
Password word lists. These are just huge text files containing lists of potential passwords. Could be common passwords, dictionary words, names, dates, or passwords leaked from previous data breaches.
The famous RockU list.
That's probably the most well-known one. Derived from a breach years ago, it contains over 14 million real-world passwords people actually used. You often find it in user-share word lists on security distros like Kalidi.
It's usually compressed though, right? JZ.
Yeah, you need to uncompress it first. Gunzip, user share word lists, rocku.txt.gz. Then you have the massive rocku.txt file ready to use.
Sometimes you might want a more targeted list based on the person.
Right. That's where a tool like CUP, Common User Passwords Profiler, comes in. You run it interactively, cut by say, feed it details about the target name, partner's name, pet's name, birth date, keywords related to their interests, and it generates a custom word list based on common patterns people use when creating passwords from personal info. Can be surprisingly effective.
And the tool to actually perform the brute force attack against a service, Hydra.
Hydra is the go-to for online brute forcing. It's fast, multi-threaded, and supports tons of protocols. SSH, FTP, Telnet, HTTP basic auth, HTTP form logins, SMB, VNC, databases like MySQL, Postgres, you name it.
Key options for Hydra.
LL for a single login username, L for a file containing a list of usernames, SGP for a single password, SBP for a file containing a password list, your word list. Then you specify the target service and address. Format varies by protocol.
Like for SSH.
Might be Hydra-L username-key path to rocku.txt ssh.target-ip. Or if you have a list of users too, Hydra-L users.txt pass.txt ssh.target-ip. Hydra tries combinations until it finds a hit or exhausts the lists.
The example shows checking SSH first with Nmap.
Good practice. Nmap-p22 target IP to confirm SSH is open, then run Hydra. If it finds credentials like user.password123, you'd verify with shush user at target IP and enter the password.
What about web login forms? That seems trickier.
It is a bit more involved. First, find the login page URL, maybe with Derb or GoBuster. Then use your browser's developer tools, usually F12, to inspect the login form's HTML sort.
What are you looking for?
You need the name attributes of the username and password input fields. You also need the name and value of the submit button, if any. And crucially, you need to see what text appears on the page when you try a wrong password. That's your failure signature.
Then you feed all that to Hydra.
Right. Using the HTTP postform module, the command structure is a bit complex. Hydra-L users.txt task.txt pass.txt target IP http-postform login.php.username login.php.username user and password pass and login failed.
Whoa, don't break that down.
Okay. -L users.txt-p pass.txt are the lists. Target IP is the server, HTTP postform is the module, login.php is the path to the login page. Then the : separates the path from the form data string. Username, user, and password pass and login. Login defines the fields to submit. Hydra replaces USR and pass with values from your lists. The final : separates the form data from the failure signature, which here is the text login failed. Hydra tries combinations until the response doesn't contain login failed.
Makes sense. Is there a graphical version?
Yes. Hydra provides a GUI front end if you prefer clicking over typing long commands.
The ATC hands-on example involves basic auth.
Yeah, it seems Derb finds a directory like admin that gives a 401 unauthorized, triggering a browser pop-up login. That's HTTP basic authentication. Hydra can attack that too, often using the HTTP GET module since the credentials are sent in the headers of a GET request. Something like Hydra-Nutshell admin-commonpasswords.txt target HTTP-get admin.
Okay, brute forcing isn't just for logins. Password-protected ZIP files.
Yep, common CTF challenge. Tools like Fraxzip or the more general Patater can handle this.
How does Patater work for ZIPs?
You use its unzip-pass module, you tell it the zip file secret.zip, and where to get the passwords, then link FileLitter0 to your word list. 0 path to rocku.to0. The command looks roughly like the Patater. Unzip-pass zip file secret.zip 0 path to rocku.txt password to FileLitter0. It tries each password. You can add nash-ignore.code 0 to only show the successful attempt.
Once you have the password, just unzip it normally.
Exactly. Unzip -- the correct password secret.zip.
Last brute force target. Hashed passwords. What's a hash again?
A hash is a one-way cryptographic function. You put data in, like a password, and it spits out a fixed-length string of characters, the hash. Crucially, you can't easily go from the hash back to the original password. Systems store hashes instead of plaintext passwords for security.
So how do you crack them?
You don't reverse the hash. You take a guess. like a password from a word list, hash it using the same algorithm, MD5, SHA1, bcrypt, etc., and see if your generated hash matches the target hash. If it matches, you found the original password.
Tools for this: John the Ripper, Hashcat.
Those are the big ones. John the Ripper, or just John, is a classic. Hashcat is very powerful, especially with GPUs for speed. There are also online services like CrackStation that have huge pre-computed tables of hashes, rainbow tables.
How do you use John?
First, you often need to get the hash into a format John understands. Sometimes tools like unshadow or specific scripts like zish2john, zip2john help here. Then you can run John hash file for a default dictionary and rule-based attack, or John wordlist path2rockyou.txt hash file for a pure dictionary attack, or John incremental hash file for a pure brute force attack. Trying all character combinations can take forever for complex passwords.
Okay, let's talk Metasploit. Huge framework. What's the overview?
Metasploit framework is basically a platform for developing, testing, and using exploit code. It's modular, making it easier to manage different attack components.
Key module types.
Exploits: the code that takes advantage of a specific vulnerability, payloads. The code that runs on the target after the exploit succeeds, for example, giving you a shell. Auxiliary: modules for things other than exploitation like scanning, fuzzing, denial of service. Post-exploitation modules run after you gain access for things like gathering info or escalating privileges. Encoders, used to try and obfuscate payloads to evade antivirus. Nops, used to pad payloads.
How do you start it and interact?
Just type msf console in your terminal, you get the msf6 prompt. Help lists commands, help search explains the search command, etc.
The Sweet CRM hands-on example. What are the typical steps in using Metasploit?
Okay, first you'd search for exploits related to the target software. Search suitharmer. Find a likely exploit module, maybe exploitunix web appsudi hamster serializers, then use it. Use exploitunix web appsudic mun serializers.
And configure it.
Right. Show options lists what you need to set. Common ones are ROSTs, the target IP address or addresses. RPort, the target port like 80 or 443, maybe target turi if the app is in a subfolder. You set these with set. Set ROSTs 10, 0.0.0.50, set RPort 80.
What about lhost and lport?
Those are for payloads that connect back to you, reverse shells. Lhost needs to be your IP address. Find it with ifconfig or ipadger in another terminal. Lport is the port on your machine you want the connection to come back to, or shell 4444. Set LHO 192.4168.1.10. Set lport 4444.
Check options again.
Always good. Show options, make sure everything required is set. Some exploits have a check command to see if the target seems vulnerable before actually exploiting.
Then launch the attack.
Yep. Exploit or run. Using exploit-j runs it as a background job, letting you keep using the console.
And if it works?
You might get a session open. Use sessions or sessions LT to list active sessions, then sessions ISessioned to interact with one.
This often leads to a meterpreter session. What's that?
Meterpreter is Metasploit's advanced in-memory payload. It gives you a powerful interactive prompt on the victim machine without writing much to disk. It has its own set of commands for exploring the system, uploading, downloading files, manipulating processes, taking screenshots, etc.
Basic meterpreter commands.
Sitsinfo for system details. Get TUID to see who you're running as. .ls to list files. BWD for current directory. .cd to change directory. Upload, download files. Execute to run commands. .ps to list processes. Type help within Meterpreter to see all its commands.
Can you get a regular shell from Meterpreter?
Usually, yes. Just type shell, you'll get a standard OS command prompt. Type exit to get back to Meterpreter. Type background in Meterpreter to put the session in the background and return to the SCAS console. Another exit from Meterpreter closes the session.
Okay, shifting gears completely. Network traffic analysis with Wireshark. What is it?
Wireshark is the world's most popular network protocol analyzer. It lets you capture network traffic flowing across an interface and dissect it packet by packet. Incredibly useful for debugging network issues, learning how protocols work, and in cybersecurity, finding sensitive info sent in the clear, analyzing malware traffic, or performing reconnaissance.
How do you start capturing?
Run Wireshark. Often needs sudo to capture. It shows your network interfaces, Ethernet, Wi-Fi. Double-click the one you want to monitor or choose any. Traffic starts appearing immediately.
What does the main window show?
A list of packets. Each row shows packet number, timestamp, source IP, destination IP protocol, TCP, UDP, HTTP, DNS, etc., length, and some summary info. Below that are panes showing details of the selected packet, protocol layers, and the raw byte data.
Capturing everything can generate huge files quickly, though.
Oh, yeah. It's best to capture only when needed and apply capture filters if possible, or just keep captures short and focused. Click the red square button to stop capturing.
The real power is in filtering the captured data, right? Display filters.
Absolutely. That filter bar at the top is key. Type filter expressions there to narrow down what you see.
Examples. Filter by protocol.
Simple, just type the protocol name, HTTP, DNS, ICMP, ARP, TCP, UDP.
Filter by IP address.
ETR equals 10.0.0.1. Traffic to or from that IP. IP.src equals 10.0.0.2. Only traffic from that source. IP.dst equals 10.0.3. Only traffic to that destination. TCP.port equal 80. TCP traffic is using port 80 as source or destination. UDP.port equals 52.3. You can specify direction. TCP.sc.src port equals 12345. TCP.dst port equals 443.
Combining filters.
Use logical operators and or NN or not or not. Example, IP.ADR on MTT.ADR on IP.dst 1.102 and not TCP.port equals loads oats. HTTP.request.method equals postheat. HTTP.request.URI contains login. HTTP.response.code equals 44. HTTP.useragent contains curl. Very granular.
The hands-on involves capturing web traffic.
Yeah, a common exercise. Start capture, browse to a site, especially an unencrypted HTTP site. Stop capture, filter for HTTP. You can then see the GT requests, responses, headers, maybe even credentials if it was a plain HTTP login.
Following streams.
Very useful. Right-click a TCP or UDP packet in a conversation. Select follow a NASH TCP stream or UDP stream. Wireshark reassembles the data exchange between those two endpoints and shows it in order. Great for reading protocols like HTTP or FTP. Requests might be red, responses blue.
Can you extract files sent over the network, like images?
Yes. If files were transferred over HTTP, go to File and Export Objects-HTTP. Wireshark lists the objects it found. You can select them and save them to your disk.
The example involves analyzing a capture file. Capping.
Right. You might download a capture file from a CTF challenge. Open it in Wireshark, apply filters, follow streams, export objects to find flags or clues. Another example is analyzing a wireless capture.cap file. You might use air cracking first to check if it contains the necessary handshake packets, then use air cracking with a word list to try and crack the WP-POC2 password captured in the handshake.
Okay, two more related topics. Steganography and cryptography. What's steganography?
Steganography is about hiding information within other seemingly harmless data, hiding a message inside an image or an audio file or even text in a way that someone wouldn't suspect there's anything hidden there. Unlike crypto, the goal is secrecy of the message's existence.
Is it actually used maliciously?
Yes, increasingly. The materials mention things like hiding card skimming code in website images, malware, or crypto miners in audio files or images, even using memes to distribute malicious code. Espionage uses it too. It's hiding in plain sight.
StegHide is a tool for this.
It's a popular command line tool for hiding data in JPEGs, BMPs, WAV audio, etc. It can compress and encrypt the hidden data with a password.
Key options.
Embed to hide data. WOF specifies a file to hide, embeddable file. WGOVC specifies the cover file, the image audio you're hiding it in. WP sets the password. To get data out, -SF specifies the stego file, the file containing the hidden data. -SF specifies the name for the extracted file.
The hands-on involves embedding text in an image.
Looks like it. Create secret.txt. Download image.jpg. Embed using steghide embed -aef secret.txt-cf image.jpg-password 123. Check with steghide info image.jpg, lies password. Extract with steghide extract-sf image.jpg-xf output.txt password 123, then cat output.txt.
What if you have the stego image but don't know the password?
You need to crack it, like password cracking but for steganography passwords. StegSeek is a tool mentioned for this, specifically designed to brute force steghide passwords using a word list. Install with sudo apt-get install stegseek, then run stegseek wordlist path-rock-u.txt stegoimage.jpg. If it works, it usually extracts the hidden file automatically.
Okay, files also have metadata, data about data.
Exactly. Information embedded in the file that describes it. For photos, EXIF metadata is common camera model, date time taken, GPS coordinates where it was taken, documents have author, creation date, software used, can reveal a lot.
How you viewed metadata. EXIF tool.
EXIF tool is the Swiss Army knife for metadata. Free, command line, supports tons of file types. EXIF tool photo.jpg shows everything. EXIF tool photo.jpg grep GPS filters for GPS info.
Can you remove metadata for privacy?
Yep. EXIF tool can do it. EXIF tool-all photo.jpg removes all-gps.all, removes just GPS. The mat2 tool is also mentioned, specifically designed for cleaning metadata from various file types. mat2 file to clean.est. Run mat2 by s file to see metadata first, then mat2 file to clean it, creates file.clean.ext. EXIF tool can even modify metadata, like changing the GPS coordinates to spoof the location.
Right. Finally, cryptography, encoding info securely.
Yep. Using algorithms to scramble data so only authorized parties can read it. Basic historical examples are the Caesar cipher, simple letter shift, and the Vigenère cipher uses a keyword and a grid much stronger than Caesar.
What's the main difference between symmetric and asymmetric encryption?
Symmetric uses the same secret key for both encryption and decryption. Sender and receiver need to share that key securely beforehand. Fast, efficient examples. AES, DES, Blowfish, also the classical ciphers like Caesar Vigenère.
And asymmetric.
Asymmetric, or public key, uses two related keys, a public key and a private key. The public key can be shared widely and is used to encrypt data. Only the corresponding private key, kept secret by the owner, can decrypt it. Solves the key sharing problem. Examples, RSA, ECC.
The materials show GPG for symmetric and OpenSSL for asymmetric.
Right. For symmetric with GPG. GPT symmetric myfile.txt. It asks for passphrase. Encrypts to myfile.txt.gpg. Decrypt with GPG. Decrypt to myfile.txt.gpg gets the passphrase. You can even try cracking GPG passphrases using GPG to John to get a hash for John the Ripper.
And asymmetric with OpenSSL, RSA example.
Yeah. First, generate key pairs. For Alice, OpenSolo genersa out aliceprivate.pem 2048, generate private key, then OpenSolo RSA and aliceprivate.pem-pubout out alicepublic.pem, extract public key. Bob does the same. Alice encrypts a message for Bob using Bob's public key. OpenSolo pql encryptan-pubinat inky bobpublic.pem and message.txt out encrypted.bin. Bob decrypts using his own private key. OpenSolo tql decrypt and genesis inky bobprivate.pem in decrypted.bin out decrypted.txt. Private keys must be kept absolutely secret, often protected by another passphrase.
Wow. Okay, that was a lot to cover. A real deep dive.
It really was. From CTFs and Linux basics through the whole hacking lifecycle, recon, scanning, exploitation with web bombs and brute force, Metasploit plus network analysis with Wireshark, and finally Stego and crypto fundamentals.
Yeah, pretty comprehensive overview based on that bootcamp material.
Yeah.
Gives you a solid map of the territory.
Definitely. But remember, this is foundational. The real learning comes from practice, from actually doing these things ethically, of course, in CTFs or home labs.
Couldn't agree more. So here's something to think about for everyone listening. Given all these different techniques, from passive recon to complex exploits, what do you personally think is the most underestimated aspect of cybersecurity, either for individuals or organizations? Something people maybe don't pay enough attention to.
That's a good one. Definitely worth considering. And maybe try applying some of these CTF principles, that puzzle-solving, find-the-flag mentality, to how you approach security in your own life or work.
Yeah, definitely. Check out the tools, explore further, keep learning.
And maybe test your recall with these. First, can you explain the practical difference between Nmap's SYN scan -SS and a full TCP connect scan -ST? Why choose one? Second, think of a scenario where a simple security misconfiguration, maybe a default password or an exposed service, could realistically lead to a major breach. Third, what are those key steps again for using Metasploit, from finding an exploit to getting a session? Fourth, how would you use Wireshark specifically to look for usernames or passwords being sent unencrypted over HTTP? And finally, a crucial one. What ethical boundaries should always be respected when you're practicing or learning these kinds of skills?
Great questions to review. Thanks for joining us on this deep dive. Until next time, keep exploring, stay safe out there.